Okay, in this section we're going to talk about tail recursion, a particular form of recursion that's particularly important in Erlang programming. Just to recall, we talked about direct recursion where we describe the result, the function that we write almost directly describes the result that we want. So we said factorial of n is factorial of n minus 1 times n. That is as close to a specification as you can get, but it's an executable function definition. So factorial of 0 is 1. The factorial of n is the product of factorial of n minus 1 and n. So that's the style we've seen. How about this function? It's also going to compute factorial, but it says factorial of n is defined to be factorial, 2-argument factorial applied to n and 1. Okay, but what are the n and 1 doing here? Well, factorial of 0 and p just returns p. So the final result of the computation is going to be in that second parameter. What about the general case? When n is bigger than 0, factorial of n and p is factorial of n minus 1 p times n. We simply call the function again. So here, this isn't a direct description of anything. It tells us we've got to loop. We've got to loop, and we call the function again when n is greater than 0. So let's see what it does on factorial of 3. Factorial of 3 becomes factorial of 3 and 1, 2-argument factorial. 3 is greater than 0, so that becomes factorial of 2 and 3 times 1. Factorial of 2 and 3 becomes factorial of 1 and 3 times 2. Factorial of 1 becomes factorial of 0 and 6 times 1. And now we have factorial of 0 and 6, which is the answer 6. So what's happened here is that effectively we've used the second argument as a place to accumulate the result. We can call that an accumulator. And in fact, this general pattern where the last call in our body, if there are any recursive calls there, the last call, that's called a tail call, and that can be implemented very efficiently without using a stack for the function call, because it's effectively a loop. The parameters act like variables, and as I said, this extra parameter here is what's called an accumulator, and that's the place that we store the result so far. So it starts off being 1, and then we multiply it by 3, and then by 2, and then by 1, and we get the final result 6. So it's a much more operational. To understand what's going on here, we have to understand the operational behaviour of this function. And that's because it's just like a loop with the parameters playing the role of variables, and in particular an accumulating parameter to collect the result. And you'll find that a lot of Erlang functions, particularly when we're writing concurrent code, are processes which have this sort of tail recursive description of their body because they loop through, for example, receiving a message, processing it, receiving a message, processing it, and so on. So that's a pattern that we see very often. Just to reinforce that, let's look at another example. Here's a loop function that, when called with n greater than 0, calls the function IO format, and then that rec should be a loop. I thought I'd change that. And calls loop at n minus 1. And then when loop at any other case, just calls IO format with by. What it does, if we call loop of 3, is it prints the result 3, then 2, then 1, then by, and the final result of the last IO format is the value OK. Now, here's a general piece of information. I've used a new function IO format. How on earth do you find out about what that does? Well, I can tell you here what it does. It's a formatting function, so for every placeholder twiddles p, that gets format inserted into the string from the corresponding position in the list. So here we've just got one twiddles p, so that takes the value n and puts it into the output string. And twiddles n is new line. But in general, if you want to find documentation, we go to www.erlang.org/doc, which lists all the Erlang modules in the Erlang distribution. What I usually do though is Google Erlang and the module name, and that usually takes me there. So there's a separate video that will show you a bit about that, so you can look at that. But this summarizes all that we need to know about documentation. And just to go back to the example, what we have here is a function which simply performs a loop. And you can see that again, we do some actions like the IO format, and then we have the tail call. And that's like the loop back to the beginning of the body. Okay, so a couple of examples for you to try. If you've got a function f from integers to integers, write me a function that will sum the values f of 0 up to f of n, or find the maximum of those values. So those are a couple of things for you to try. And what we'll do next is you'll do some exercises, and then to reinforce what we've done about general recursion, direct recursion, and tail recursion, and then we'll pull the week's work together in a final video. Okay, that's it.